E-commerce attacks analysis ontology based on CAPEC and CVE. Abstract: security is the most important feature of electronic banking services. E-commerce is one of these services, and its safety is the one of the uppermost visible security that controls the end user during interacting with their business. Sharing sensitive data in insecure medium raises security and privacy issues. Credentials and personal data can be theft by hackers. This leads to the need to secure the data exchanged between the bank and the customer. Efforts have been made to analyze attacks, know their causes, and determine ways to mitigate them. But the analysis process needs to extract knowledge from different sources, present it in a simple and easy to understand way. Here the need to rely on ontology appears. Ontology allows collecting information from different formal and informal sources, integrating and reusing it effectively. Attack analysis based on ontology can make understanding the risks much easier and faster, so this facilitates escaping them. Relying on CAPEC and other formal resources enriches the analysis process and gives the information great credibility. Keywords: e-commerce, attack, ontology, CAPEC, CVE. Introduction. E-commerce was introduced to the consumer and business worlds as a unique approach in 1990. E-commerce is characterized as a primary business model by means of the selling process of goods, the purchasing of resources, and the distribution or exchange over the Internet. The popularity of e-commerce is mainly because of its online business perspective. It makes it possible to gain and sell goods online, to provide various services and information through the Internet, and to exchange money immediately between businesses. E-commerce implies an electronic purchasing and marketing process online by using typical web browsers. It is described as selling and buying of services or goods through wireless technology using electronic payment systems that have continued to grow over recent years because of the increase of online banking and shopping. Through electronic payment systems, any person can transfer money and purchase items any place and time based on Internet, and without visiting banks. Since the Internet is the medium of data transmission, there are risks to the confidentiality, integrity, or availability of data exchanged between banks and the customers. The presence of vulnerabilities in devices, applications, or network may lead to exploit by unknown organizations or persons who are not authorized to access this information, in order to achieve unethical goals too. Hence the importance of analyzing e-commerce attacks. This analysis requires large amounts of data to know the goal of the attack, requirements for achieving goal, attack tools, vulnerabilities that led to its occurrence, attack strategy, and the stage in which it may occur. The analysis process needs information from various sources, including some global knowledge sources for vulnerabilities and attacks such as CWE, CVE, and CAPEC, which enables us to obtain more information related to the attack and vulnerabilities. Semantic-based knowledge management systems are the best suited for these analyses by using ontology. Ontology is a description of a set of concepts, their characteristics, and the relationships between them, and is used for the integration of knowledge and building a conceptual model, as it is used as part of an intelligent system or a distance learning system. Ontology-based systems use descriptive logic in which concepts and relationships are described in a formal way. 2L Literature Review. In 2018, L-Ork, Bajat and N. Al-Hayat proposed an approach able to detect and prevent suspicious transactions on various electronic payment systems using ontology. The approach makes to share and adaptive the preventives rule of fraud on an ontology based on multiple and various payment systems. In 2018, Rosa and Bonason proposed security ontology to assess security to reach secured systems. The concept of security assessment is inherited from two concepts: systems evaluation and information security. Two software applications have been developed. The first receives a list of evaluation elements, their dimensions, and security features, then calculates the extent of information security coverage. The second supplies a graphical interface to generate evaluation designs. In 2018, Fens and Neubauer suggested security ontology equipped with a decision support system to provide a way to formalize the information security features, verify its compliance with the official controls of ISO 27002, and identify the missing measures to ensure compliance and reduce risks to an acceptable level. 6. In 2018, Syed and Joan developed an ontology-based conceptual model for managing vulnerabilities. This model integrates concepts from both formal sources like CVE and NVD, and informal sources like social media. This ontology extends the vulnerability concepts provided by the National Institute of Standards and Technology, NIST, and can be used as a general vocabulary in vulnerability management. It can be useful for thinking about entity relationships to issue security alerts for vulnerability analysis and management. 7. In 2018, Kotenko, Fedorchenko, Doinikova and Chekulin proposed an ontology-based approach for storing security data to link security data from various internal sources such as intrusion detection and prevention systems, network scanners, event logs, etc., and external ones such as CVE, CAPEC, and NVD, etc. The use of ontology allows easily merging data from different sources, and allows the use of more accurate queries and reduces the time required to process the query. The experimental results showed that using ontology enhances the management of system security. But the disadvantage of this method is that it depends on the quality of the data stored in the ontology. In 2019, Wen and Cat proposed a security ontology to manage the security knowledge of the software considering the context of the application, as the software developers should not only have a general knowledge of security concepts, but also about the context in which the software is developed. The ontological representation supports the integration of knowledge resources in the various levels of abstraction and advanced search for knowledge, thus supporting the process of sharing and learning about program security. Reliance on ontology is very important in many applications. This ontology has contributed to sharing a common understanding of public security concepts, ensuring application security during its development stages, and neglecting the risks that could face the application after launching and using 9. In 2019, Brazik discussed the problem of extracting and using knowledge from general dictionaries related to software attacks and their weaknesses to build semantic models of the threat. The aim of the model is to use it as a kernel of a knowledge management system in the field of software security. The reason for using the ontology is the multiplicity of knowledge sources in this field and the difficulty of manually analyzing them. The ontology can be used as part of an intelligent system or a distance learning system, and it uses descriptive logic whose main characteristics are to describe concepts and the relationships between them in a formal way with the possibility of thinking and deduction. 3. Electronic payment systems. Electronic banking is a set of devices using electronic and computer technology to develop banking transactions. It refers to all the technologies necessary for the use of bank cards and the switching and processing of transactions made from them. Electronic payment systems have become more popular thanks to the increased use of internet shopping. These systems do not only concern internet transactions, as more and more resources are being developed to facilitate electronic money transfers. With the increase in technology, the range of devices and processes used to conduct electronic transactions continues to increase as the use of cash and check transactions decreases. This is mainly because it is much easier to carry cards or use cell phones to pay for purchases over money. 4. Electronic payment system components. Cardholder. A client is a person who is going to purchase items by creating payments in a timely manner. Merchant. A merchant is an enterprise or a person who offers a service or product. Card issuer. A kind of bank that holds the client's account and authorizes him or her during account registration. It generally has the money of numerous customers and is specially designed for the goal of keeping the client's cash on trust. Acquirer. A merchant bank is a monetary institute, which involves underwriting and company loans, catering mainly to the requirements of big companies and individuals with substantial net worth. In e-commerce, a merchant bank is a kind of bank that permits companies to accept payments through credit or debit cards and is liable for fraud management. Payment gateway. Every transaction that takes place online is created via payment gateways. A payment gateway is attached wholly to consumers, banks, and merchants through the internet and is responsible for the speed, reliability, and safety of all transactions. 1. E-commerce transaction phases. Cardholder registers on the merchant's website. 2. Cardholder logs into the merchant's website. 3. Cardholder searches for the items, selects them, and adds them to the shopping cart. 4. Cardholder chooses the type of electronic payment. 5. Cardholder goes to the electronic payment system. 6. Cardholder enters his personal information, his bank account information and card information. 7. Merchant sends the information to the acquirer that sends them to payment gateway. 8. The payment gateway checks with the customer's bank, to ensure that the card is valid and that there is sufficient balance for the transaction. 9. If the customer's bank is approved, the amount will be deducted from the customer's account. 10. The customer's bank sends a confirmation to the payment gateway. 11. The payment gateway sends a confirmation to the acquirer who sends a confirmation to the merchant. 12. Merchant informs the buyer of the confirmation of receipt of the purchase price. 13. The buyer gets a notification from the issuing bank, and the procedures for sending the product to the buyer's address begin. The most dangerous phases are the 7th and 8th phases, where sensitive data transmission. In these phases sensitive data can be under attack by an unauthorized attacker, which poses a great threat to banks and customers. 1410. For formal resources CAPEC, CVE and CWE. A CAPEC. CAPEC is abbreviation for Common Attack Pattern Enumeration and Classification. It released in 2007. It provides a publicly available catalog of common attack patterns that helps users understand how adversaries exploit weaknesses in applications and other cyber-enabled capabilities. Each attack pattern captures knowledge about how specific parts of an attack are designed and executed, and gives guidance on ways to mitigate the attack's effectiveness. Attack patterns help those developing applications, or administrating cyber-enabled capabilities to better understand the specific elements of an attack and how to stop them from succeeding. The CAPEC list continues to evolve with public participation and contributions to form a standard mechanism for identifying, collecting, refining, and sharing attack patterns among the cybersecurity community. CAPEC helps by providing a comprehensive dictionary of known patterns of attack employed by adversaries to exploit known weaknesses in cyber-enabled capabilities. It can be used by analysts, developers, testers, and educators to advance community understanding and enhance defenses. Through CAPEC records, we can obtain the following information. Attack ID. Description of the attack. Prerequisites. Mitigation methods. Related weaknesses, CWE. Likelihood of attack. Attack severity. Required skills. Scope. Technical impact. 11. BCVE. CVE is abbreviation for Common Vulnerabilities and Exposures. CVE program has the mission of identify, define, and catalog publicly disclosed cybersecurity vulnerabilities. Each vulnerability represented in one record. The vulnerabilities are discovered, assigned, and published by organizations that have partnered with the CVE program. Information technology and cybersecurity professionals use CVE records to ensure they are discussing the same issue, and to coordinate their efforts to prioritize and address the vulnerabilities. CAPEC not directly connected to CVE. It directly connected to CWE, which in turn is connected to CVE. So we will get to know about CWE, and in our research, we will use ontology relations to achieve this link between these different sources. 13. CCWE. CWE is abbreviation for Common Weakness Enumeration. It is a list of common software and hardware weakness types that have security ramifications. Weaknesses are flaws, faults, or other errors in software or hardware implementation, code, design, or architecture that if left unaddressed could result in systems, networks, or hardware being vulnerable to attack. CWE has a goal to stop vulnerabilities at the source by educating software and hardware architects, designers, programmers, and acquirers on how to eliminate the most common mistakes before products are delivered. Ultimately, use of CWE helps prevent the kinds of security vulnerabilities that have plagued the software and hardware industries and put enterprises at risk. We can obtain the following information from CWE records. Weakness description. Observed examples that represent CVE records related to CWE records. Detection methods of the weakness. CAPEC records related to CWE records. 12. Reliance on official sources gives high value to the analysis process and great information credibility. Thus, linking the analysis of electronic banking attacks with CAPEC, CWE, and CVE dictionaries will enrich the analysis process with information that will lead to an understanding of how the attacker exploits the vulnerabilities in order to prevent a successful attack. But these sources are not directly related to each other. For example, CAPEC is not linked to CVE directly, but the connection is achieved through CWE. Since CAPEC records are linked to CWE records, and CWE records are linked to CVE records, we will achieve the linking between these formal sources on the one hand, other sources of security knowledge on another hand, and the e-commerce concepts on the other hand, by using ontology. Ontology. Ontology is the mainstay in the field of semantic web to represent concepts and their relationships, and make the knowledge machine understandable. Through ontology, we can understand the structure of knowledge that well reflects the complexity of the real world. It stores and processes knowledge, and contains not only raw data, but also the meaning of this data. By creating a common vocabulary about the concepts of a field and the relationships between them, the ontology enables sharing a common understanding of the information structure between people and software agents, reusing knowledge and making domain assumptions explicit. Besides automated computer heuristics, the adoption of ontology will enable reliable data entry, easier information sharing, homogeneous training, and software development among different actors. Ontology consists of classes, attributes, relationships, function terms, restrictions, rules, axioms and events. Ontology is a good way to systematically categorize different security concepts, such as vulnerabilities, attacks, countermeasures, and the relationships among them. It also plays a significant role in collecting and analyzing large amounts of data, storing and reusing them later. Risks analysis based on the ontology can make understanding these risks easier and faster. This makes them easier to resist and get rid of them. 14. 6. The proposed ontology. A. Ontology concepts. The top-level concepts of the ontology of e-commerce attacks analysis based on CAPEC and CVE shown in Figure 1. Our ontology contains concepts related to e-commerce systems such as e-banking that represents electronic payment system with all components. Services that represent electronic services like e-commerce. Card that represents the customer's card which be used to do e-payment. Account that represent customer account in the card issuer bank. Order that represents all purchases that customer buys. Bill that contains the price of all purchases. Person who is the card _holder or merchant. Purchases that refers to items which the customer buys. Transaction _phase that represents the stages of the e-commerce service, and it is the connecting point between the concepts of electronic commerce and security concepts. Payment _corporation _network that represents the payment network that transmits data among banks and the customer. And the financial _institution that is either card _issuer bank or acquirer bank. There are concepts related to information security risks analysis like attack, that represents the attack can be occurs, and it divided into 3 groups, communication _channel attacks. Internet _banking _server attacks, user _terminal attacks, that shown in Figure 2 and Figure 3. Vulnerability refers to weakness or vulnerability that can causes an attack. Attack _goal refers to the attacker target of doing attack such as stealing information. Attack _goal requirements refers to things which attacker should do to achieve its goal. Attack _tool refers to tools used by attacker to do attack. Mitigation _strategy refers to methods should be done to mitigate attack. Scope refers to information security goals that attack can affect if it occurs such as confidential, availability authorization, etc. Technical _impact refers to the impact that can attack causes, such as read data, modify data, etc. B. Ontology relationships. A. Object properties. Ontology concepts linked each other by relations. Figure 4 Figure 5 shows the basic relations between the concepts. Has _card refers to card holder has a legitimate card. Associate _with refers to a legitimate card associates with an account. Issue _card refers to the card issuer issues a legitimate card. Buy _purchases refers to the card holder buy purchases. Sell _purchases refers to the merchant sell purchases. Contracting _with refers to the merchant contracting with the acquirer. Form _order refers to purchases form order. Has _bill refers to the order has bill. Processed _by refers to the bill processed by e-banking system. Runs _services refers to e-banking system runs services. Consists of refers to the service consists of transaction phases. Happens at phase refers to an attack can be occurs in a specific transaction phase. Attack has goal refers to any attack has a target to achieve. Attack goal achievement requires refers to things that should happen to achieve the attack goal. Exploits vulnerability refers to an attack exploits a weakness or vulnerability to occur. Impact technical impact refers to an attack can cause technical impacts if occurs. Mitigated by an attack can mitigate by mitigation strategies. Scopes refers to an attack may affect information security scopes. Uses tools refers to an attack uses tools to occur. B. Data properties. Attack strategy refers to the method that can attacker use to do attack. Scores exploit likelihood refers to likelihood of a successful attack. Scores required skill refers to skills that an attacker needs to do the attack are high, low, medium, etc. Scores severity represents the severity of the attack if it occurs. Detected by represents the method of detecting the weakness. 7. Implementation and using. The proposed ontology is represented as an ARL file, using Protégé Ontology Editor. The proposed ontology allows providing multi-aspect analysis of e-commerce attacks and vulnerabilities. To illustrate this, below is shown the ability of the ontology to answer queries represented as SPARQL queries. For example, the request which attacks with high and very high severity, high likelihood, and low required skills can affect e-commerce service. The corresponding SPARQL query 1 is the request in which transaction phase of e-commerce service can sniffing attack occur. The corresponding SPARQL query 2 is select attack happens at phase, where XRDF type n sniffing, XN happens at phase, KN transaction phase name, attack happens at phase. Order by attack happens at phase. And the result is in figure 8. The request what is farming attack goal. The corresponding SPARQL query 3 is select attack goal, where XRDF type n farming, XN attack has goal, KN goal name, attack goal. And the result is in figure 9. The request what is man in the middle attack ID in CAPEC records? And what are the severity, likelihood, and required skills for this attack? The corresponding SPARQL query 4 is select attack ID, exploit likelihood, required skill, severity, where XRDF type n man in the middle, XN attack ID, attack ID, XN scores exploit likelihood, exploit likelihood, XN scores required skill, required skill, XN scores severity, severity. And the result is in figure 10. The request what are weakness that cause man in the middle attack according to CWE and CAPEC. The corresponding SPARQL query 5 is select attacker exploits vulnerabilities, where XRDF type n man in the middle, XN exploits vulnerability, KN vul name, attacker exploits vulnerabilities. And the result is in figure 11. The request what are vulnerabilities related to CWE 1286 according to CWE and CVE. The corresponding SPARQL query 6 is select observed examples, where RDF type n vulnerability. Optional, AN observed examples, observed examples. Optional, AN vul name, X. Filter, X equals CWE 1286, improper validation of syntactic correctness of input. And the result is in figure 12. The request what are scope and technical impact of farming attack according to CAPEC. The corresponding SPARQL query 7 is select scopes, technical impact, where XRDF type n farming, XN scopes, KN scope name, scopes, XN impacts technical impact, SN imp name, technical impact. And the result is in figure 13. Our ontology also answers many other inquiries regarding e-commerce attacks and the vulnerabilities that cause these attacks. 8. Conclusion and future work. In this research, we proposed ontology to analysis e-commerce attacks. Analyzing process dependence on formal resources like CVE, CAPEC, and CWE. This ontology contains information about e-commerce attacks and vulnerabilities. This ontology can be used by analysts, developers, testers, and educators to understand attacks and enhance defenses. This ontology can be expanded in the future to include studying of other attacks, or by adding other e-banking services and analyzing their attacks, or even by increasing sources of knowledge and relying on other official sources.